Everybody have a good weekend?
Yes, but you.
Okay, good weekend. Yes, it very was. Got my lawn mowed before the rain hit, so that was very nice timing. So this week's going to be a short week. You know, Friday is Good Friday, so you get yourself a 3-day weekend just before Easter happens on Sunday. But a couple things that we're going to be doing this week. We should be able to wrap up the current lesson on writing the equations of lines tangent to functions today. We'll go ahead and wrap up those problems. You got your homework assignment right here. Let's go ahead and have that due Wednesday. I've got another focus activity that I'll go ahead and give you tomorrow, and we're going to go ahead and turn those in on Wednesday as well. I'm just going to have 2 in this set because I don't know if I'm going to have time to get any more written. I'm probably going to go ahead and give you an exit ticket tomorrow that is going to spiral back in some material we haven't seen in a little while, and we'll go ahead and talk about it afterwards. But the big item is on Thursday. That's your what? That's your exam. Okay, so it's going to cover our introduction to calculus, limits. We're also going to have, derivatives, the difference quotient, power rule, finding the slope, okay, the gradient of a secant line, all that good stuff that we've been talking about. And in fact, I thought it would be a good idea, since we hadn't seen one of these in about a week and a half, 2 weeks, to go ahead and practice this. Unfortunately, I didn't have time to make copies for everybody, and I do apologize about that. But we can take a look. So let's say we've got a piecewise function that looks like this. So it says find the following limits. Now, what's this notation mean if I have a negative where a power would be? That approaches it from the left. Okay, if positive is from the right. And if there is no symbol at all, then we're approaching it from both sides. So remember, the only way that the limit as we approach -1 can exist is if we approach the same y value from both sides, the left and the right. Okay, so let's see. The limit as x approaches -1 from the left. Okay, Karime, can you help me out with that? According to this function, if I'm approaching -1, okay, from the left, the function's approaching something. It is approaching 2. There we go. It is approaching 2. Let's see here. Carolina, what about the limit as x approaches -1 from the right? Okay, it is approaching 2 as well. So because it's approaching the same value from both sides, what is the limit as x approaches -1? It is 2. Now be careful. If I were to evaluate the function, let's just call this function f. If I were to evaluate the function at -1, then it would be what? 1. Okay. But what the y values actually approach, remember one of the ideas that we talked about was it doesn't have to be necessarily defined at that location in order for the limit to exist. You guys okay with that? Okay. Well, what about the limit as x approaches -4? Okay. Now this one, let's go ahead and look at this in a couple of different parts here, if this will erase. So we're going to -4, but there's no symbol, so we do want to go ahead and take a look at it on both sides. So as I approach -4 from the left, what's the graph approaching? Looks to me like it's approaching 3. Okay. As I approach -4 from the right, what's the graph approaching? It's approaching 4. So from both sides, this function is approaching different values. So what would I say for D? Does not exist. That's exactly right. Does not exist. Perfect. And we can go ahead and tell the same situation is taking place here. This is what we call a jump discontinuity, because the function seems to just jump from one value to the other. But if you take a look, as we approach 4 from both sides, same thing happens. From the right, we approach -2. From the left, we approach -3. So that one does not exist either. Okay. I did actually go ahead and put a couple of little graphs like these on the test and then give you some questions that followed. Okay. So anything about that? Anybody not sure how we got an answer, how we determined it, the values? Good to go? Okay. Well, let's see how far we got the other day. So we're writing the equation of tangent lines. So this whole unit has been basically a progression of the big idea. We started with limits, then we started talking about the derivative being found using the difference quotient, then we moved on to the power rule, and then we're finishing up here writing equations of lines using that derivative. Okay. So looks like we have this third example here to finish up. Find the equation of the tangent line to f of x equals x squared plus 1 at the point 310. Now, it's been a while. Does anybody want to go ahead and practice using the difference quotient just one more time to get that in, or stick strictly with power rule? What would you guys prefer? You do want to go ahead and practice? Okay. So what was the difference quotient? F of what? X plus h minus f of x, all divided by h. Okay, now this was just going to go ahead and find the gradient of the secant line. If I went ahead and took the limit as h approached 0, that's what we called the first derivative, the first principles, okay, that IB refers to it as. All right, so we already have f of x, but I want f of x plus h. So x squared would become x plus h squared plus 1. And somebody expand that for me. X squared plus 2xh plus h squared plus 1. Perfect. So I'm going to take this four-term expression. I'm going to go ahead and plug it in for f of x plus h. So x squared plus 2xh plus h squared plus 1. And now I'm going to subtract f of x. Okay, so I'm subtracting a binomial, so I'll just go ahead and distribute the negative as I do so. So that would be minus x squared minus 1. And of course, this is all divided by h. Okay, well, what is going to cancel? Okay, so the x squareds are out. Also, okay, the 1s are out. And now let's go ahead and divide everything by h. So it looks like I have 2x plus h. Okay, so now that is the gradient of the secant line. So if I take the limit as h approaches 0, any term still containing an h just disappears. So the derivative should be 2x, which is exactly what I would get if I were to apply the power rule to x squared plus 1. How does that work again? Like, how do I take the derivative of x squared? Multiply the exponent by the coefficient and decrease the exponent by 1. What's the derivative of a constant? 0. There we go. Okay. So now, find the equation of the tangent line. So there's two things I need. We have the point. Okay. But now I need to know what the slope is at that particular location. Remember, that's what the derivative is going to help me figure out. So what am I going to plug in to find the slope? 3. We want to plug in the x value at that coordinate. So 2 times 3 is going to give me 6. So I know we need a slope of 6. And we have a point 310. And I think what we were doing the other day was we did focus on point slope form in order to get the equation we want. But you can plug directly into y equals mx plus b if you'd rather do that. Do you guys want to try it a different way, or you want to stick with point slope?
Can we do both?
You want to do both? Yeah, sure, let's do both. Okay, so let's say we want y equals mx plus b. Well, the only thing we don't have is the y-intercept. Okay, so I'm going to plug in everything. So y equals becomes 10 equals. The slope m, 6 times 3 plus b. So 10 is equal to 18 plus b. So what is b? Negative 8. There you go. So once you have the slope and the y-intercept, remember all you got to do is just plug them in and you have your line. So y equals 6x minus 8. There we go. Now if I were to go ahead and use point slope, what was that general form again? Y minus y1? There we go. Okay, so in this case, x1, y1 is still that same point. So y minus 10 is equal to the slope m6 times x minus 3. Okay. And you'll notice you're going to get the same values because when you distribute, y minus 10 would then equal 6x minus 18. And then I'm going to add the 10 over. So we still get 6x minus 8. Okay. So either way you want to go ahead and take a look at it. Okay, the slope, Okay, of the line turned out to be 6, so the equation of the tangent line at 310, 6x minus 8. Questions? Okay, well, let's see what else we got. Find the coordinates of any points on the curve with equation f of x equals x cubed plus 3x squared minus 9x plus 5, where the tangent line is horizontal. Okay, so this time we're working backwards. We want to figure out what values of x and then use those to find the point or points that's going to give me a slope where a line is going to be horizontal. So I made sure not to go ahead and say it. What's the slope of a horizontal line? Is what? It is 0. So there we go. That's the slope that we're interested in. Okay, so how am I going to do this? What do I need to do first? Okay. There you go. If you're wanting to find the locations where it happens, set the derivative equal to the slope you're looking for. All right, so what is the derivative of f? 3x squared plus 6x minus 9. There we go. I'm going to set this guy equal to 0. Now, we can go ahead and solve this any way that you like. There is something that we could also do to make things a lot easier. There you go. We could just go ahead and divide that 3 out. Now, it is going to give me a different graph, but both parabolas are going to have the same roots. They'll have the same values of x that make it 0. So we'll just go ahead and say x squared plus 2x minus 3 is equal to 0. So that makes things so much easier. All right, so now I automatically went ahead and started writing it out like factoring, but we can use the quadratic formula. Remember, we graphed these. Did we ever do completing the square? I think maybe I asked about it, but I don't think anybody was really interested in it. Okay, so are we okay to go with factoring, or do you want to try something different? Sounds good. Okay, so two numbers that'll multiply to give me -3, but have to add to give me 2. So it's definitely 1 and 3 because it's a prime number, but which one's negative? The 1. Okay. Now, this is the factored version of my quadratic, but how is that going to help me find the solution to the equation? There you go. What was that called again? What property? The zero product property. So if x minus 1 equals 0, x plus 3 is equal to 0, we have x equals 1, x equals -3. Okay. Now, are we done with the problem?
No, just don't. Can we go into the exciting?
There we go. See, we want to know the actual coordinates of the points. So we know where the x values occur, where this is going to happen. So one of my answers has got to be 1 something. The other one's got to be -3 something. But in order to figure out the corresponding y value, we have to plug it back into the original function. Okay, because what coordinate on the original graph is going to have a tangent line with a slope of 0? Okay, so let me take this off here. So let's start with 1. F of 1. That would be 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. Okay. So what would that be? 1 plus 3 minus 9 plus 5. Be 0. Okay. So one coordinate where that would happen would be at 1, 0. Okay. And the other one, let's go ahead and plug in -3. So that would be a -3 cubed plus 3 times -3 squared minus 9 times -3 plus 5. And honestly, off the top of my head, I don't remember what that one was. Is that what you guys are getting? No. I don't have my notes in front of me, so I honestly don't remember. Did you want me to type it in? Or...
So it's -27 minus 27.
Okay. So let's see. This is -27
Plus 27.
plus 27. So those are out.
And then minus 27.
Plus 27 plus 5.
So it's 32.
So I'm getting 32. Is that what you said?
I said -22.
-22. Okay.
I got what?
So 32. Good. Okay. Now, they might go ahead and ask you to go ahead and find certain points on a graph that are going to have tangent lines with, say, positive slopes, negative slopes, or even zero. In calculus, using the derivative and setting it equal to zero is a really great way to go ahead and find what's referred to as your maximums and your minimums. But since graphs like these are going to continue forever, upward and downward, we refer to them as relative maximums and minimums. Do you guys remember that from Algebra 2? No? Okay. Well, let me go ahead and graph this for you very quickly. X cubed plus 3x squared. X cubed. Okay, get out of there. Plus 3x squared. And what is it? Minus 9x plus 5? Okay. All right. Okay. Now remember, what were the two values of x that we got? Okay, 1 and -3, right? So the other maximum is going to look up here. This will be known as the relative minimum because the graph is going to continue forever to infinity, both upwards and downwards. But because there is no maximum value or no minimum value, we refer to those as minimum, okay, relative minimum or relative maximum. So if I were to go ahead and get a tangent line that's horizontal at a particular location, well, that's basically what we were doing there. Is everybody okay with that? Does anybody want me to zoom out so you can see the other one? Would be up there at 32? I'll take that as a do. All right. Then I will go ahead and erase this. All right. And let's get back over here. Okay, next up. Find the coordinates of the point on f equals negative x cubed plus 3x, where the tangent has a gradient of -3. Okay, so it's the same type of problem. Would anybody like to come on up and show me what to do? Okay, we've only got so many weeks of school left. You won't have the opportunity again, so I want to come up, yay. Very quiet. Oh, nobody wants to come up? Okay. Then I could always use a random number generator. Okay, so for this class, I'm going to have to set it to 27, because I believe that is the seat Jocelyn's in. Okay, so any volunteer before I go ahead and push the button? Okay. I got 14. Marissa. It's okay, Marissa was about to volunteer anyway. So we're good. Okay. Okay. Gradient is another word for slope. So we're provided the slope. We want to know the coordinates where we have a tangent line that would give me that slope. Okay. So f prime, we'll go ahead and find the derivative. So -3x squared plus 3, perfect. And then we'll set it equal to, there you go. Yes, I'd go ahead and subtract off that 3 because we want to isolate x squared. Okay. Not yet. I do one more thing before we took the square root. Perfect. Okay. So the square root of 2, we're absolutely right. There's just one thing we're forgetting. Okay. Well, plus and minus. There we go. So that would actually tell me that we have how many points where this happens. 2. Okay. There we go. To which one? You talking about the original or the derivative? The original, yes. Okay, good. Okay, now if we're getting one thing, what has to go with that 2? The radical, there we go. So we're looking at the square root of 2 or the negative square root of 2. Mm-hmm. Oh, let's make sure to put that negative on the outside, because what happens if we take the square root of a negative? That gives imaginary. There we go. Okay. All right, and now we just need to figure out the corresponding y values. So negative square root of 2 cubed plus 3.
Would this be -2
It would still be the same. So the one you began with, or you're pulling it in the positive, then it would be just 3 square root of 2. Yeah, John, thanks. Oh, if you would put that. Okay, so we know it's going to be negative no matter what, because the negative is going to apply after the cube. So basically, what's square root of 2 times square root of 2 times square root of 2? That would be 2 square root of 2. There we go.
So 2.
Mhm. Okay, and now we'd apply the negative.
Wait, what?
Well, don't forget the negative, because it was negative x cubed, right?
Yes.
Okay.
But I put the negative here.
No, put the negative right out in front of the 2. There we go. And now plus 3 square roots of 2. And it's just like using the radical as a variable. If we had negative 2x plus 3x, you would tell me what? Yeah, just 1x, right? So negative 2 square roots of 2 plus 3 square roots of 2 would give me 1 square root of 2. Okay. There we go. And now we want to do the same thing, but we're going to plug in now a negative square root of 2. Okay. And I'll go ahead and give you the option. Did you want to keep going, or did you want somebody to help you with this last part? Okay. Well, I'll tell you what, I'll let you choose since you've done a lot of work. So many hands. How will you choose? All right. Okay. Alejandra's going to put it in there. Okay, so now we're going to take negative x cubed plus 3x, and we're going to replace x with a negative square root of 2. Okay. So let's put a negative on it. True, because I mean, when you cube it, you're still going to end up with a negative, and that negative will cancel. So, okay, we can do that. Okay, cubed plus 3x. So 3 times negative square root of 2.
And then, yep, doing that.
Oh, we don't need a calculator. What's square root of 2 times square root of 2 times square root of 2? 2 root 2. Now that would be plus or minus? Minus what?
1.
Oh,
What is it?
3 square root of 2. And what would 2 square root of 2 minus 3 square root of 2 give me? And again, think of it in terms of a variable. What would 2x minus 3x yield? Minus 3x would give me what? Negative 1. Okay. All right. Negative 1 square root of 2. There we go. Okay, questions. Problem was radical. Man, is it just because it's a Monday? What's going on? It's really quiet today. You thought that problem was pretty gnarly? Cool. All right. I believe we have one final problem. And then after that, you got your assignment. Okay, so the curve with equation y equals ax plus bx squared passes through the point 2, 0, where its gradient is found to be 3. Determine the values of a and b. Okay, now I'm sure there's different ways to go ahead and solve this. What I did was create a system. Okay. Would you like to solve this together? Would you like the opportunity to try on your own? You want to do it together? Okay. All right, let me go ahead and walk you through what I did. Okay, so here's what we know. We have a function. We have no idea what a and b are going to represent, but it goes through the point 2, 0, and has a gradient of 3. So we can at least go ahead and do what we've been on the previous problems. Let's go ahead and start with, if this is function f, ax plus bx squared, let's find the derivative. Now, just think of a as a real number, just some constant. Okay. So what would the derivative of ax be? It would just be a. That's right. Same thing for b. So the derivative of bx squared plus 2bx. Okay. So remember I said we were going to go ahead and create a system. So that means I need 2 equations. What can I do? Remember, one of them is based off of what we've been doing in the previous examples.
Set them equal to 3.
Okay, but which one? The original or the derivative? Okay, so I'm going to take the derivative. I'm going to go ahead and set that equal to 3. So a plus 2bx is equal to 3. Okay, now what?
And wouldn't x be 2?
There we go. Okay, because we know that x is 2. So if I go ahead and plug 2 in there, we actually have a plus
A plus 4b.
4b is equal to 3. So that's going to be one of my equations. But now we do have another one. We know that the point, whatever that function is, does go through the point 2, 0. So for the original, this is an x and a y value we can use.
0 equals 2a plus 4b.
Okay, and there we go. Do you see how I was able to get my 2 equations? And then did you say just, and then math? That's right. Okay. So however you want to solve the system, you've got A and B. Think you guys can take it from here? Okay.
So where did we get that 2A from?
Where do we get the 2A? This one right here? Oh, because for this one, this equation, okay, the original helped me get that one. We just went ahead and plugged in the point 2, 0. See, instead of y equals, we put the 0 equals. X is 2, so 2 times A, and then we had B times 2 squared. Okay. All right. Okay, so what were some of the methods we talked about in here to solve a system? Elimination, substitution. I did show you how to use matrices. We're taking the inverse matrix times the constant matrix. I think that was all we had time for. I didn't show you like Kramer's or anything, did I? No. Okay. All right. So this one, I actually think the setup was probably a little more difficult than actually, the math that goes with it. Just getting to that point. Now, actually, there is another way where you don't have to use any math at all. Actually, I did show you. You remember? What am I referring to? If you now have the system and you want the answer.
Oh yeah,
You can just put your equations in the calculator. But where's the fun in that? We want a math. Man, it is really quiet today. I tell you what. Not excited. It's a short week. You're in your favorite class. Easter's on Sunday. I don't know. What's that, Eli? All right. Well, how should I solve it? Not using technology. Let's actually solve it by hand. You want substitution? Okay. Do you want to solve for A or B?
I solved for A in the first.
In the first equation? Okay. So A plus 4B is equal to 3, so we know A would equal 3 minus 4B.
And then I just put that in.
There we go. So I'm going to replace that in the other equation. Remember, that's key, always plugging it into the other equation. So 0 equals 2A, so 2 times A we know is 3 minus 4B, and then we have the plus 4B at the end. And see, now we have an equation all in one variable. Well, almost fell. Okay. And we'll just go ahead and solve it. So 0 equals what?
6 minus 8.
Oh, did someone knock? Hello. Okay. Louise. It says when convenient, so we're almost done. All right, so it looks like we're going to have, let me go ahead and do a couple things at the same time. I'm going to subtract the 6 over. Negative 8b plus 4b is a negative 4b. Divide through. And what do we get for b? 3 halves. How many people had that? Okay, good. And now it's just a matter of plugging it back in and finding a. So I'm going to use the equation that's already solved for a. 3 minus 4b. So 3 minus 4 times 3 halves. Okay, so what's 4 times 3 halves? 6. 3 minus 6 is negative 3. There we go. So the function that we should be working with is a negative 3x plus 3 halves x squared. Okay. Questions? Anybody having a hard time derivatives, finding the points, anything? Okay. Then we are done for the day. We still have a good 8 or 9 minutes. You have your homework assignment. That's going to be it's going to be due on Wednesday. Okay. Hopefully I should be able to maybe give you some time tomorrow, but I would like to go ahead and start looking through that review tomorrow. Speaking of how many people have had the opportunity, a few more hands are going up. Okay. So we'll start looking, and that pretty much now that we're done with our last unit, that's what's going to be happening. We're just going to be reviewing, because 4 weeks from today, we take our paper exam. Okay. All right. I'll go ahead and give you another review packet tomorrow, and we'll just move on. All right. Thanks, sir. Have a good weekend, or have a good day.